We talked about electrons off and on, the hydrogen atom, the electron going around the proton. Let's kind of put all those questions together and let's think of all the things we looked at all term. So a hydrogen atom has an electron orbiting around a proton. Let's just draw a quick picture of that. So we have a proton right here, then going around and around in a circle is an electron. Let's say that the electron is right here, and at this point it's moving upwards in a circle like this. Question 1, and the radius of the hydrogen atom from here to here is 53 picometers, where a picometer is times 10 to the minus 12 meters. So question 1, what is the electric field at the electron due to the proton? We know that the electric field due to the proton is K times Q over R squared. So 8.99 times 10 to the 9 times the charge of a proton, 1.6 times 10 to the minus 19, divided by the distance between the electron and proton squared, 53 times 10 to the minus 12 meters squared. Put that through the calculator and we should get 5.12 times 10 to the 11 newtons per coulomb. Electric field is a vector, so we need a direction, and the direction is out from proton because the proton's positive. Okay, let's move on to part B. What is the electric force on the proton? Well, for this we could either use Coulomb's law, K Q1 Q2 over R squared, or we could remember the relationship between the force and the electric field. Now we remember that force is charge times electric field. This charge means the charge on the electron, so the proton makes the electric field, that charge goes in there. The electron feels the electric force, so the charge of the electron goes here, minus times the fundamental charge. So we do 1.6 times 10 to the minus 19 times the electric field we just found right here, and we get 8.19 times 10 to the minus 8 newtons, negative. What this negative means is that the direction is opposite that of the electric field, so we could also say in toward the proton. So that would be another way to say it. Okay, part C, what is the speed of the electron orbiting the proton? Well, the electron is going around in a circle. The force on it is the electric force. So we must have circular motion here. Here's our proton, here's our electron, goes around in a circle. It has a force that points towards the center. So we're talking about centripetal or circular motion. The sum of the forces equals mass times acceleration. The net force is the electric force. So 8.19 times 10 to the minus 8 newtons equals the mass of the electron times the acceleration, but going in a circle, we know that the acceleration is v squared over r. M is the mass of the electron, 9.11 times 10 to the minus 31 kilograms. So we can solve for v. V is equal to our force times our radius, we'll bring our r up here, divided by our mass, and that gives us v squared. So to get v, we take the square root of the whole thing. That turns out to be 2.18 times 10 to the 6 meters per second. Actually pretty fast. It's about 0.7% times the magnitude of c, so the thing really zips around there. Okay, so that covers the electric stuff. In the next one, we'll do the magnetic stuff.